In the grand expanse of our solar system, the Webb telescope has made some unexpected discoveries that are challenging our understanding of space. The Webb telescope, a marvel of modern astronomy, has embarked on a mission like no other. A journey to the edge of our solar system, where the sun's warmth barely reaches and the deep infinite expanse of space begins. This is a realm that has remained largely enigmatic until now. But thanks to the Webb telescope's advanced technology and the relentless curiosity of the scientists who operate it, we're beginning to peel back the layers of these distant regions. Among the myriad celestial bodies that dwell in this far-off territory, two have recently caught the attention of our intrepid explorers: Eris and Makemake. These aren't your run-of-the-mill planets. They're dwarf planets, smaller than the ones we're familiar with, yet no less intriguing. Eris, a hefty contender in the cosmic scale, is even more massive than Pluto, which for a long time was considered the ninth planet of our solar system. It belongs to a group of celestial objects known as trans-Neptunian objects, an array of bodies that reside in the Kuiper belt, beyond Neptune's orbit. Makemake, on the other hand, is slightly smaller but equally captivating. Its orbit is slightly closer to the Sun than Eris's, but it's still far beyond what we typically consider the boundary of our solar system. The Webb telescope has been diligently studying these distant bodies, capturing detailed observations and relaying them back to Earth, where eager scientists pore over the data, searching for insights about our universe. And what the Webb telescope discovered on these distant celestial bodies was nothing short of astonishing. The evidence suggests that both Eris and Makemake could each have a warm core, producing methane. It's a revelation that not only challenges our understanding of these dwarf planets, but also opens up new possibilities for what lies beyond our solar system. On the icy surfaces of Eris and Makemake, scientists found something they didn't quite expect: methane deposits. Picture two dwarf planets orbiting in the frigid outer reaches of our solar system, far beyond Neptune. This is the realm of Eris and Makemake, members of a collection of celestial bodies known as trans-Neptunian objects. These outliers of our solar system have long intrigued scientists, and recently they've given researchers a whole new reason to marvel. A team of scientists turned the gaze of the James Webb Space Telescope towards Eris and Makemake, and what they saw was remarkable. Both dwarf planets, despite their distance from the Sun, were covered in deposits of methane ice. Now you might wonder, how did methane, a compound we often associate with life and warmth, end up on these distant icy worlds? To find the answer, our scientists embarked on an investigation, the results of which were published in the scientific journal Icaris. They studied the origin of these methane ice deposits and came to a fascinating conclusion. The most likely source of this methane wasn't an external one. Instead, it seems to have originated from within the dwarf planets themselves. Yes, you heard that right. The cores of Eris and Makemake, despite their location in the chilliest neighborhood of our solar system, might be warm. These warm cores could be producing methane, a possibility that puts a whole new spin on our understanding of these distant worlds. But the methane mystery doesn't stop there. After all, if the methane is being produced in the warm cores of these dwarf planets, how does it end up on the surface encased in ice? It's a question that has scientists scratching their heads, and one that promises to lead us on a captivating journey into the heart of these mysterious celestial bodies. But the question remains, how did this methane make its way to the surface? The journey of methane from the warm cores of Eris and Makemake to the surface is a story of convection and ice. Nestled deep within the heart of these dwarf planets, the warm cores are thought to generate methane. This methane, in its quest to escape, embarks on a journey that's both fascinating and complex. How, you ask? Well, this is where our story takes a chilly turn. Picture this. Methane molecules born in the warmth of the core travel through an icy crust. This is not a journey made in haste, but one that requires the right conditions. You see, these dwarf planets possibly have what we call convection processes within them. These processes are like a moving elevator, carrying the methane from the core through the icy crust and finally to the surface. It's a bit like a journey from the Earth's core to the surface, but on a much smaller, colder scale. Now, what makes this journey even more intriguing is the possibility of liquid water. Yes, you heard that right. Liquid water on a dwarf planet that are more than 3 times the distance from the Sun than Neptune. The methane, as it travels through the icy crust, could potentially be creating pockets of liquid water beneath the surface. This is because the heat from the methane could be melting the ice around it, leaving behind a trail of water in its wake. It's a tantalizing thought, isn't it? The possibility of water in such distant, cold corners of our solar system. But what's the proof, you might wonder? Well, here's the intriguing part. Researchers suggest that the methane on the surface of these dwarf planets has been cooked recently. This means that the cores are still warm, still generating methane. So if the cores are warm and the methane is making its way to the surface, it could very well mean that there is liquid water under the ice crust. If the methane on the surface has been cooked recently, as researchers suggest, it means the cores of these dwarf planets are still warm. An intriguing possibility, isn't it? To truly grasp the significance of these discoveries, we need to understand the sheer scale and distance of these dwarf planets. Eris, the more massive of the 2 dwarf planets, boasts a diameter of 2,326 kilometers. That's smaller than our own moon, which measures in at 3,474 kilometers. Despite its smaller size, Eris carries a significant amount of mass, thanks to its dense composition. As for its location, Eris resides in the farthest reaches of our solar system, beyond the orbit of Neptune. At its most distant point, Eris orbits the Sun at a distance more than 3 times that of Neptune. Imagine that. A celestial body, part of our very own solar system, at such a staggering distance that it takes light itself several hours to travel from there to here. Now let's turn our attention to Makemake. This dwarf planet is slightly smaller than Eris, with a diameter of 1,434 kilometers. That's about half the size of the Earth's moon. But don't let its size fool you. Makemake, like Eris, is packed with a dense mixture of rock and ice, making it a significant member of our solar system's family. Makemake's orbit around the Sun is slightly closer than that of Eris, yet it still lies far beyond Neptune in the realm of trans-Neptunian objects. This region, known as the Kuiper Belt, is home to a multitude of icy bodies, remnants of the early solar system. These unexpected discoveries on such distant celestial bodies not only broaden our understanding of our solar system, but also remind us of the vastness of the universe we are a part of. The findings of the Webb telescope have profound implications for our understanding of the solar system. The exploration of Eris and Makemake, 2 dwarf planets beyond Neptune, has uncovered fascinating possibilities. The detection of methane ice deposits on these celestial bodies suggests that they both may harbor warm cores, generating methane that finds its way to the surface. This sheds new light on the nature of these trans-Neptunian objects and opens up intriguing questions about the potential for liquid water hidden beneath icy crusts. If convective processes are indeed carrying methane from the core to the surface, it implies that the cores of these dwarf planets are still warm. These revelations not only challenge our current understanding of these distant celestial bodies, but also broaden our perspective on the potential conditions for life beyond our planet. These discoveries are a testament to the power of exploration and science, continually reshaping our understanding of the universe we inhabit.